Okay, so now let us talk about capacitors and inductors. Now, aside from resistors, capacitors and inductors are energy storage elements which store energy in the form of electrostatic or electromagnetic fields. Now, first, let's start with a capacitor. The formation of a capacitor happens when you have two parallel conducting plates that are separated by some distance d but are not touching each other, and they have some area A and separated by some distance D. Now, what ends up happening is that when you apply the presence of an electric field, the parallel conducting plates will get a separation of charges, forming a voltage, like so. And this allows us to actually store electrostatic energy. The good part about capacitors, too, is that they are electromagnetic interference immune. So we are able to use them to kind of block unwanted noise. So the definition for capacitance is equal to epsilon times A divided by D. That means that if you have more area, you have a larger capacitance. If you have smaller distance separation, you have also larger capacitance, which just leaves this constant. This constant is called permittivity. Basically, in a given vacuum or any kind of given medium, this just tells you how much charge you can really store into that said medium. To kind of increase this, we usually use something called a dielectric. Now, another related phenomenon is the inductor. Inductors come in all shapes and sizes, but usually their generic kind of composition is a coil. What ends up happening is that when you run current through this, you generate an electromagnetic field that looks something like so. And this helps you store electromagnetic energy. Now, what ends up happening is that this electromagnetic energy basically opposes like the direction of current, and therefore it would try to store that energy and stop the fluctuation of current. So if you had a constant DC source, you're really not going to generate a noticeable difference for inductors. Now, for inductance, they come in all shapes and sizes, but usually they take on some form like so, k squared a. So they kind of reflect a constant squared times its area. So that's just a general information about inductors and capacitors. Now, for a capacitor, we use this symbol. We have two parallel plates that are drawn about the same. Or sometimes, if we want to express a polarized capacitor, the bottom side is slightly curved. The voltage of a capacitor is equal to the capacitance the capacitance 1 over the capacitance integrating from 0 to some time t of some current tau d tau. I of tau d tau. Now, for an inductor, we usually generally use the symbol of a coil, and the voltage reflected is equal to L di dt. Notice that capacitors are better at kind of keeping a constant voltage because it takes some time for the signal to transition. So therefore, it would reflect more so on the capacitor for voltage, whereas for inductors, it would reflect for current. Now, another thing that we will talk about in the case of DC steady state is what happens when you connect them with a resistor. When you connect them with a resistor, you'll end up charging that capacitor, and it will take some time to drop that capacitance or that inductance down to a certain level, which we call the time constant. With this out of the way, we can now probably talk about what happens in the event that you fully charge up a capacitor or you fully charge up an inductor. Now, note, capacitors and inductors are energy storage elements. They're not amplifiers. So if you ever see a case where somehow the output voltage is greater than the input voltage, then we have an impossibility. Now, for capacitors, when you don't charge them, they act like a short circuit. So this is no charging. But if you charge it all the way, charged fully, it becomes an open circuit. For an inductor, it's the exact opposite. If there's no charging, it becomes an open circuit, but when charged fully, becomes a short circuit, like so. That's all there is to know about capacitors and inductors. And in the next few videos, we're going to be discussing about time constants and DC steady state analysis a little more. Okay, thank you.